So today we're going to be talking about advancing access from Linux and to Linux. So you guys got a chance to hear about Samba and some of the great work going on in Samba from presentations this morning. And we'll talk a little bit about the client, and I'll also briefly talk about the kernel server to give a little bit of an update. Namjay couldn't make it for this event this time. A reminder that these are my opinions, not necessarily others. I'm a Samba team member, but I've been maintaining a kernel file system for many, many years. And been speaking at these conferences for a long time. And I'm particularly interested in making sure that Linux accesses whatever type of server, whether it's the smallest embedded device or whether it's the largest server in the world. I don't know, is Azure Files the largest in the world now? Windows, Macs, whatever type of devices, and especially obviously Samba and ksmbd. So it was nice to see Jim McDonough here. It reminded me of histories, writing the net command a long time ago. A lot of Samba team people. There's a test event going on next door. We've been able to test a lot of things. I'm going to start out talking just an overview of Linux file system activity, because I think sometimes people find that very, very interesting, what's going on in the bigger file system world, not just the SMB world. Then I'll drop down and talk about the kernel server improvements, and then focus most of the talk on client improvements and where we're going from here. And obviously we're testing right now, so I'll be talking about testing a little bit too. So as you guys know, a few days ago, 6.6 RC2 came out. It has the strangest name. You can see this ninja sloth here. Now, think about the massiveness of the Linux work going on now. 85,000 change sets over this period since last SDC. 85,000. And 3 million insertions. Okay, so the Linux storage developers get together annually, usually in April or May. This year in Vancouver. Here you are looking over the water in Vancouver. You can see the BTRFS maintainer there. You can see an amazing group. The Linux storage team, the guys working on files and blocks, are now co-located with the BPF guys, so we get to see the way tracing is moving forward as well. And this is a fantastic group, and one of the goals I think we should try to do is make sure that the storage group here and the storage group for Linux are interacting well. I saw a few, but we could use a lot more interaction between the two. Okay, so what are the things that are being talked about generally for storage? Then I'll dive down into SMB. If you read the news stories last week, excuse me, not last year, did you notice Linus trying to work around the typical problem? glibc has some terrible implementation of fstat that causes some massive performance problem, for 15 years. But it's finally being addressed. Linus did a partial fix for this. It's kind of crazy. This is the year 2023, and we're still dealing with application problems mapping to the wrong API call. There's some things we can do in the kernel, and I got to tell you, half my life, and Paolo and others, is spent making up for weird things apps do. Okay, number one thing that I think came out of that storage summit, to give you guys some. There's work going to try to improve testing. KDevOps, for example. A lot of discussion about how don't use stable releases because they're not stable. We need to test them better. Things like Red Hat and SUSE don't have this problem because they have their own kernels, but stable releases, how do we test? I think as you saw with the talk from Metz, IOU ring is a big deal. It's the way forward for parallelization. We're trying to get away from the terrible parallelization APIs, but there's been security issues with it, so it's held off on some workloads, but this is the way forward. Folios and variable size pages, this movement to IOV iter, total redesign of the page cache. We threw away the old page cache design. I say we, Dave Howells, Matthew Wilcox, and others threw away the old page cache design. It's completely different internally. This helps things like IOU ring and parallelization, but it also helps a lot with some workloads. Unfortunately, it also breaks a lot of things. So, this last year has been an exciting year for file system developers. Okay, so we have guys like Christian Bronner and others who are trying to focus on containers and ID map mounts. He's now the co-maintainer of the VFS. There's a lot of controversy going on literally today on this, fine-grained timestamps. And if you know, well, people like Tom Talpe, I'm sure you remember the days when NFS was talking about fine-grained timestamps. Well, there's a lot of back and forth on that topic right now. It looks like this is going to be reverted and removed from the kernel. But I was following that literally going on right now. Why do fine-grained timestamps matter? Because caching timestamps and determining when something is invalid needs to be reread. For these kind of, there are models where people want to use this, especially like it came up a lot of discussions about NFS. Okay, eBPF. So that is the way forward for tracing. It used to be in the dark ages, you had static trace points. Now people are even inserting code in scary ways with eBPF. But eBPF is the Berkeley packet filter, and it's the way forward for doing dynamic tracing. It allows you the luxury of capturing just the events that you're interested in. All the syscalls, for example, are there. And there's some fantastic resources Brendan Gregg and others have, websites, books on this. There was an incredible talk 3 years ago, if you guys want to look in the archives, talking about how to leverage eBPF for storage debugging, figuring out performance problems, figuring out any storage problems, whether they're files or blocks. Dr. Hani Namadi and others did that. Okay, there's discussions with the NFS guys about TLS, but of course on the SMB side, we're trying to move to what you see in the web, which is quick. There's a Red Hat developer who's begun some work on some prototypes of that for in-kernel. Unlike Windows and some other operating systems, Linux doesn't have an in-kernel implementation of quick. So there's a portion of quick that needs to be in-kernel for performance. This is a very exciting discussion, and we had a discussion of that for a while in the Plugfest over there. And obviously the shift to the cloud. I think you heard that in the last presentation. Many, many things change as more and more storage moves to the cloud. And obviously I work in Azure, so I see this all the time, and we've had multiple Microsoft speakers talking about the optimizations in the cloud and how that changes things. And I think we've also seen over the last 5 years this movement away from half the talks being file related to more than half being block related. So obviously things like NVMe, NVMe fabrics are of interest. Okay, so these are general topics, but let's talk a little more. File systems make up over 6% of the activity in the Linux kernel. So 5,207 change sets. Actually, it's a little bit more because I looked at this last week, or 3-4 days ago. File system activity is up a little bit over last year, but that's still a lot. We've got over 1 million lines of source code in the file system layer and the file systems. That seems big until you talk to people like Volker or the Samba team. You know how big that is? 3.8 million lines of code. So his life is much harder than mine. So what are the most active? I think you all would know this, BTRFS. ext4 is up a lot, interestingly, this year, a lot. And XFS, they dominate. We've had a surge in activity in F2FS as well. And then over the last 3 or 4 years, SMB activity has usually been in the top 5 or 4 or 5. We had 340, similar to last year. That's a lot of change, that's a lot of changes. NFS had 190, 199. Actually, we're at 345 thanks to Paula, who just sent me, there you are, who just sent me some patches. The other thing that's kind of interesting is looking at the lines changed. It's been a very active year. We had 3 times the number of lines changed. There are other file systems that have activity. Obviously, ksmbd, we'll talk a little bit about that. There's been a little bit of a resurge here in NTFS3. But you can see that these others are relatively minor, and then there's about 30 other file systems that get very little activity. Okay, so what was the activity like for us? 340 change sets, we have 61,000 lines of code. It's easy to focus on. The kernel server, even smaller, 25,000 lines of code, maybe 1/10 the size of the Samba core file server code. It's kind of easy to look at. It was introduced in the 5.15 kernel a couple years ago. Samba, though, is, well, I said 3.5, it's actually 3.8 million, and is way more active than any other server, or NFS for that matter, way more active. Okay, so what are the goals? We've talked about this before, it's a repeated slide. SMB is kind of the generic way, whether you're accessing Macs, right? You got your Apple guys there. Whether you're accessing Samba, whether you're accessing Azure, whether you're accessing Windows, whether you're accessing small embedded devices, it's kind of the lingua franca, the common language for the world. And it's been around a long time, but SMB3.1.1 is very, very rich in features. Now, one of the strengths of SMB is we get together every year for these plug fests. Hopefully do more. So last year we had obviously a break with the COVID stuff. Here we have, notice in-person plug fests back right across the way. Lots of good progress. I find that very exciting. The hallway discussions help more than you'd think. Okay, I'm going to talk briefly about the kernel server. Obviously this is mainly a client talk, but since Namjay wasn't able to be here, I took a little bit of his information so I could give a little bit of an update on that. So recently we took the experimental tag off ksmbd. There's been a lot of security fixes. Does this mean it's perfect? No. There's a lot of feedback you see in the Phoronix article and some of the other news sites talking about it. We are finding bugs. We are finding, but the security fixes have had 2 years to get in, and a lot has been found, and we're seeing very good progress. In our testing event, unfortunately, we found some bugs. We'll continue to find bugs. We're not expecting all bugs are fixed, but it's certainly something that is already been used in production. As a matter of fact, it was used in production before it was merged into the mainline kernel. But we are seeing significantly higher quality. Just in the last couple days, I noticed this article that as it's getting more use, it's being added to fuzzers. So the ZDI disclosures, we're sending quite a few things as they analyze the code. Here we have another fuzzing tool that announced they're starting to look in detail at this, fuzzing ksmbd to try to find any potential security problems, because rightly so, there's a paranoia about kernel code. Kernel code can do a lot more damage than user space code. So this 35,000 lines of code or 30,000 lines of code, we have to be obsessive about making sure there are no security exposures. It's way smaller than Samba, but we have to be very careful. So what's the recent focus? Over the last year, it's mostly been stability focused and vulnerabilities rather than new features. That's a little bit frustrating for me because I'd like to see features like directory leases, or actually file leases enabled by default. But I understand the reason for the focus. Focus is on improving stability and the security things that's been, Linus is forwarding these and they're getting fixed. Every release we're seeing some. Now, they've added more broad support for compounding, even some of the ones that the Mac uses that Windows did not. So we believe that all of the common use scenarios for compounding are now covered. And of course, as we talked about last year, KSMB supports most of the POSIX extensions as well. So if you need, case sensitivity and those kinds of Linux POSIX-like behaviors, those are possible with KSMBD. So how is it different? So KSMBD is not the same as Samba. It's much smaller in function. It's GPL v2. Samba's GPL v3. Some prefer one, some prefer the other. It supports RDMA, SMB Direct. It's an in-kernel. It has great multi-channel performance. It can more directly access some of the kernel features, which helps with certain types of operations for SMB. And it's a much smaller code base, so it's kind of easier to analyze. Now, what's the next step? The plan is enabling leases by default. Literally, yesterday, Tom Talpi and I were debugging a problem with oplocks. It's awkward to have an SMB3.1.1 server using oplocks. They can enable leases, but we need to enable it by default. So when that moves forward, that'll eliminate some of these problems we see with oplocks, but it also improves performance in other ways because oplocks are much more functional than, leases are much more functional than oplocks. They are more valuable for our ability on the client to cache better. Now, when testing looks good, we'll also need to enable directory leases. Directory leases are trickier on the clients because directory leases can consume resources on the clients. We just had a performance regression discussion about Laundromat, the Laundromat thread that cleans these up on the client. But enabling directory leases will allow us to cache metadata better, which helps a lot to some things like the cloud. Metadata operations can be expensive. Being able to cache directory entries and the stat info for directory entries is extremely helpful for performance. So next step, directory leases. Quick integration. Xinlong and some others have also been talking about it, have been looking at a port of one of the user space implementations. There are 3 or 4 candidates, but it looks like they've decided on one. And then the guinea pig is the kernel client talking to the kernel server with Quick. Windows supports this. So, you know, that was discussed at the Plugfest next door. But this can help a lot. It works around the port 445 problem. It has some performance advantages for head-of-line blocking, congestion control, but it also helps with some commonly requested security configurations. You know, it's being able to encrypt with a client and a server certificate definitely can improve security in some use cases. And then finally, IOU ring integration, so better async IO. You know, separating the message processing from the IO processing, ensuring that both can achieve maximum throughput. So, you know, with the introduction of IOU ring, there's more and more opportunities also in kernel to improve async performance. So, if you're interested in contributing, Namjay would love to see more contributions. Namjay is the maintainer. I review his patches, and you know, his patches go through me to Linus. But it's a very interesting project. I was especially interested in if we can take some of the RDMA code out of the kernel server and client and put it in a common library to make it easier to maintain SMB direct code. Because there are many cases where SMB direct can achieve astounding performance with a kernel driver like this. But it's hard to maintain. Most of us don't know much about RDMA. And getting it in a separate small helper library that's used by 3 or 4 different users, including the kernel server and client, would make it easier in the long run. Okay, so let's switch gears to talk about the client now. More interesting topic for me, and something I'm dealing with every day. So there were a lot of improvements to multichannel, and I want to thank Shyam Prasad for that. And you know, there's been some really good work going on that. Now, multichannel has a couple things that are very nice now. We're dynamically requerying interfaces and rebalancing interfaces, reconnecting more often and saner now. One of the next steps, though, is going to be turning on multichannel by default. So being able to turn it on by default will help. Now, we're not going to turn it on if we don't see, you know, multiple fast interfaces or RSS, but okay, now, what else? So thanks to Paolo, who's sitting back there quietly, thanks to Paolo, we have had a lot of great work on DFS. So some examples of this, DFS interlink support. Now, interlink is where one DFS link points to another namespace in DFS. That's a nice feature. Also, the sharing of DFS connections between mounts to preserve resources. Also, reparse mounts points. So as we cross a file system boundary on the server, one of the possibilities is that we now have duplicate inode numbers, which can cause problems. So we can we automatically create submounts with no server INO, which allows us to sort of randomly generate inode numbers to avoid that problem for the submounts underneath that. Also, reconnection is much improved for various DFS use cases. And kind of a fun feature to think about is handling cases where nested links have some bad targets. One of the things that's kind of interesting is in DFS you can have multiple multiple targets for the same referral. But what if the first one's bad? It turns out that even, you know, SMB client and Windows and others have some problems that are now fixed in Linux but are broken in some of the other tools. So it's kind of neat to see the progress that Paolo and others have made with DFS. The way I think about this is DFS is a global namespace that gives you a lot of advantages. Okay, now, we have a challenge in Linux. Just 2 weeks ago, a syscall was added, fchmod at 2. You can see there were, 5 added in 5.19, and then some IOU rings, ones added in 5.17. When you think of POSIX, it's much smaller. You know, we added folios not that long ago, then changes to the NetFS and the FS cache and IOU ring. This is really tough for wire protocols that can't respond quickly. So, you know, how do we deal with this world, right? That's something we're going to have to continue to evolve protocols to deal with these new syscalls. And, you know, every year, more syscalls. Now, admittedly, these flags, these syscalls, these ioctls, most of them don't require protocol changes. But we're going to have to be able to respond much faster in Samba and ksmbd and the client to be able to add support for these. Okay, so POSIX extensions. Without POSIX extensions, you can end up opening the wrong file. So I wanted to talk about that very briefly. I gave a talk earlier this week about that. But you can see here's the case-sensitive examples. Notice that they're all dumping the same file, right? This is not good. Case sensitivity can matter. So that's without POSIX extensions. With POSIX extensions, all that works. It dumps the right file data out. But if you have two files with exactly the same name, case sensitivity can matter in some Linux examples. If you want to build the kernel, it can help. We support that with ksmbd, with Samba now, and with the Linux kernel client. Okay, here's an example of POSIX extensions. Notice in this example we're using Samba, current Samba, and notice that the stuff matches well, statfs. The network is reporting exactly what you expect. If you wanted without POSIX though, it can get confusing. Notice what you see without the POSIX extensions doesn't match. So, you know, the POSIX extensions that we now support in the Linux client can help to Samba, can help to ksmbd, and hopefully to other servers in the future. You can see without them, it can be confusing to the app because the local version and remote version of the same file data looks different. Metadata looks different. So, there is still work to do. So if you look at this example, you know, hard links, symlinks, okay. You can see that. This is the local view of it. To ksmbd, we're reporting the mode bits properly. We're reporting the ownership properly, but we're not reporting a local symlink. And similarly, FIFOs, we wouldn't be reporting those. They look like regular files in an LS listing. So it's much better. Ownership, mode bits look good. statfs look good, but we don't recognize certain special file types. Now, server-side symlinks now work to Samba. Notice both types of symlinks, the MF symlinks, the Minstrel French, the Apple-style symlinks, and the server-side symlinks both work to Samba with Volker's current code. FIFOs, Paolo, where did we get on the FIFOs? We were literally just fixing that a few minutes ago. It works now. So thanks to Paolo, we now have fixed that. Carrier and block devices, we have a small thing to do, but fortunately they're not big. So to give you an idea what it looks like in a Wireshark trace, you know, you can see you get the stopped on symlink error message come from the server, and we have enough information now to process that and just show you in the stat information what that symlink is. So POSIX extensions, very little changes. You have a new info level for getinfo and a new info level for getfsinfo and a POSIX open context, hardly anything. And I'm very excited that things are starting to work well. Okay, so let's go through very quickly what's changed in the last year. We had performance optimizations for directory search. We cached the root directory content as of the 5.19 kernel. We have these reconnect improvements I talked about earlier. There are some RDMA improvements in 5.19. Some of them done at last year's SDC, thanks to Metz and Tom Talpe. The beginning of that migration to the new design, read folio, release folio started. And then we added a new mount parm. Some people hate mount parms. This is an advanced mount parm, but we ran into a case where a server we thought had broken sparse file support didn't work. So to work around that case, sparse file support is on by default, and most Linux file systems expect it. But there are cases where if a server had broken sparse file support, we needed a way to turn it off on mount, so we don't try to do any sparse file operations. So that mount option hopefully won't be needed for much, but it's there. Okay, 6.0 kernel, fallocate improvements. We were doing a lot of XFS tests and found a few places where we weren't flushing the data properly. That's there. We shrunk the module size. We want CIFS off. Obviously, we don't want SMB1 We don't want the insecure stuff, so when that's disabled, the module has the advantage of being much smaller and a little bit faster. Okay, we added a mount parm close timeout to allow extending deferred closes for handle leases, or even disabling the feature. So if you want to cache files longer, so for example, if you open a file, write to a file, close it, maybe 5 seconds later if you open it and then read it, you don't want to have any network data sent. Nothing needs to be sent over the network. So being able to reconfigure the close timeout allows you to, for your workload, extend it even longer. If you wait 30 seconds before you reread a file you just closed, maybe this would help you to increase the timeout, but the defaults are fine for most cases. And we did some important deferred close fixes as we tested that more. And there were multi-channel performance improvements. In the 6.1 kernel, we improved path revalidation, better use the cached entry for subdirectories if a lease held. We also expanded the cache directories to include subdirectories thanks to Ronnie Sahlberg. We're still working on kind of optimizing the performance and kind of the back-end algorithms for determining what we cache and when we cache. There's a limit on how much we cache, but trying to set these optimally is still work in progress. But we do have the ability now to cache directories, so if you do ls repeatedly of the same directories, you don't have to send network traffic. We have a new ioctl for change notify that lists the files that change. There was a workload customer that wanted to cache files locally by themselves, but be notified if the server copy changed. That worked. We had that code already in an ioctl because iNotify, the Linux API for this, doesn't work over the network. It's only for a local file system. So we added an ioctl for this that returns what files change. So you can have an app that wants to cache files offline. When a file changes, it tells them what file changes. Okay, so we improved the symlink handling, we talked about that, and more RDMA improvements. On 6.2, we improved POSIX extensions. There are more DFS improvements to reduce the number of round trips, and there were some important multi-channel and reconnect improvements. But the biggest change probably was this new kernel page caching. You know, getting rid of the deprecated write page and write pages API that have been around for 20 years and moving to the new folios, IOV editor, the new memory management layer. That was a fairly large change that went in February. On the 6.3 kernel, ID mapping improvements, better MM integration, more RDMA improvements, many multi-channel and DFS fixes. And then we lowered the default deferred close timeout because we found that in most workloads the default was too high. So 6.4 kernel, a very important deferred close. So when you had a lease break, you've closed all the files. We had minor changes there to help that use case. We also had more reconnect and DFS fixes, and then there was a I shouldn't have said expected. Anyway, we had some crediting improvements. I shouldn't have said expected there, sorry. On the 6.5 kernel, there were some low credit perf issues where we were allocating credits kind of in the wrong buckets. This is used for flow control. We did deferred close perf improvements because we were in some cases sending an unneeded lease break for files that were already closed. We also added a debugging improvement that can help. If you had an empty target directory, there was no way to dump the decryption keys for Wireshark to use because it required you to pass in a file name to the dump keys to get the key back. You needed to read the Wireshark trace. This allows you to do it for a directory, even an empty directory. And we also added some improvements to debug data. There was a case with network namespaces and containers where you needed to know why the network couldn't be reached. And the reason for that was the network namespace changed. This allows you to dump the network namespaces and debug information in case you had a problem where somebody was changing the network namespace on the fly and you couldn't reach the target when you reconnect. And we also display the client GeoID, which makes it easier to correlate with Azure logs or Samba logs. What we're working on right now, 6.6 RC, we're at RC2, has some DFS fixes. These improvements we talked about for handling reparse points, for querying reparse point symlinks, reconnect improvements. We also added 2 mount parms to let you kind of test more optimal settings for directory releases because we really don't have a good feel for how much directory information should be optimally cached, and we need more feedback from users. So we added a maxed cache DIRs, the maximum number of cache DIRs, and also a dir cache timeout, which is a module parameter that lets you control how long directories are cached, the directory entries are cached, and also how many can be cached. And the reason for this is that we don't want to consume too much resources initially, but we want to allow feedback from you guys on what works better for your workload. Volker.
Wouldn't that be better to be adaptable dynamically while the mount is active?
Oh, absolutely. And that was a point that, so Volker's question was, wouldn't this be better to be dynamically adjusted while it's mounted, right?
Manually.
Or manually. So I would have liked to, you can actually update this on the fly, but I think you're right that the dir cache timeout would have been better as a mount parm. It just was it was tricky to do it that way. So what we're trying to do is, since this is more of an advanced feature, do something simple, low risk. We could have added another mount parm for that, like I said, but it was a little bit tricky the way it was would have been coded. So the max cache DIRs is a mount parm. The other one is a global parm that can be set in sysmodule sys parameters or in INS-mod. Dynamically, we're going to need to adjust these kind of things based on the workload. We don't know how to optimally do this yet, but in the short term, we have the ability to cache this information. It's great. We'll get some performance benefits from it. And then as we get smarter about setting the default values for these and deciding when to cache and when to release, I think you're going to see even more performance improvements. This is a very powerful feature of SMB, directory releases. And by the way, for context here, the ksmbd stuff is turned off by default for direct releases. Samba does not have direct releases yet, but it is a Windows thing. Does Mac support direct releases? So Apple supports it. And I assume NetApp and others. I haven't tried recently, but a large number of servers support direct releases, but not Samba yet. Okay, there were new dynamic trace points added, and there's some Git trees for some debugging scripts for eBPF leveraging trace points and debugging CIFS better. I do want to remind you guys that if you ever have a problem performance analyzing something or debugging something and eBPF doesn't have the trace point for you, we want to add your trace point. Trace points are basically free. They don't cost anything in terms of, there's no load on the system, they don't increase memory, whatever. They're basically, these dynamic trace points are they don't cause a performance problem until they're turned on. So we strongly encourage, if you guys have cases where you're trying to debug something and need an additional trace point, just let us know and we'll add it. These sometimes can be as little, we just added two yesterday for RDMA. They were like literally 2 lines of code. Okay, so what features are we working on? For the coming releases, we're analyzing cases where direct releases could better optimize network traffic while caching safely. Today, the approach that NFS and SMB often uses is things like AC timeout, AC dirmax, AC regmax, which are unsafe. I mean, in some cases they don't cause problems, but direct releases are much safer for caching. We want to also use compounding in more examples. You can see some examples on the next slides, but as we're going through things in the Plugfest, we want to have the fewest round trips possible. Sometimes it's very expensive in the cloud to go a long distance to the server multiple times when you only need to do it once. You can send these, that's a feature of SMB that's very nice. Also, we continue to focus on multi-channel performance improvements, including what's the optimal number of channels we should default to, because we want to turn multi-channel on by default. We also want to turn POSIX on by default. Not quite ready, but we're getting there. Compression support. We have some good work that Enzo and others have been prototyping. Now, here's an example of trying to optimize something. If you look at this, this is the case of creating a symlink. If you look at creating a symlink, there's an extra, we could compound these to have fewer round trips. If you look at the case when you do an LS, same thing. There's some places we could do like create, read, close, right? save round trips, improve performance. Here's an ls-l. If you look at this, we have a repeated open read on the same file. We could optimize that out, that repeated open read close. So both compounding and removing the extra one can improve performance. Now this is with MF Symlink's example, but it's an example of the kind of things we're trying to look for to reduce the round trips, take advantage of SMB features to be even more efficient. So we're also expecting to see improved packet signing, support for new auth mechanisms, and we had that discussion recently about the local KDCs, re-enabling swap file support, which was temporarily disabled as they changed the the memory management backend. I have patches that I'm almost done with for TMPFILE support, which recently, as a result of the discussions I had at the File System Summit a year and a half ago, is now possible to do over a network file system. We have to do the same kind of thing for FI Notify and iNotify to make it available for a network file system. We talked about the SMB over quick, and we have to do a lot more testing of the SMB POSIX extensions. So one of the things that literally we're working on literally right now is being able to create special files. That's a fairly minor change to be able to create the FIFOs, Karen block devices. Okay, reconnect improvements we talked about, enabling multi-channel by default, and reducing the unnecessary lease breaks by passing lease keys better. I want to briefly talk about compression support, and then I'll have to close out. Enzo provided this information, Enzo at SUSE. The goal here is to reduce the message size on large reads and writes, decreasing the network load and increasing the bandwidth and throughput. MSSMB2 describes this in some detail, and Windows supports it. Goal is to keep it simple. The API design only does pattern v1 and LZ77. There are other mechanisms possible, but we're trying to keep it simple. The trade-off, of course, is between CPU memory usage and the smaller size. You've reduced what you have to send, but you don't want to chew up too much CPU in the process. So to achieve this, only writes above over 4K, and that's similar to what I think Windows is doing. Write requests larger than 4K can be compressed. Ned mentioned in the talk yesterday that Windows is improving their use of compression support on the wire from Windows to Windows. He's still doing benchmarks on this, Enzo, and the patches weren't quite ready to include in 6.6, but let's hope they get in 6.7. So if you look at the performance, you can see some pretty dramatic performance improvements here. But this is the Microsoft Windows client and server demo, and it shows significant performance benefit to compression. So, compressed SMB I/O could be 6 times faster. And there's no reason that similar results couldn't be achieved on Linux. So the current issues he's dealing with is, hogging of memory here, and he's still working on the decompression for large reads. But he is expecting to post patches to the Linux mailing list soon. What I love about this is a great example of how rich the protocol is and how much wonderful work we can still do that makes improvements in real workloads that customers would care about. So I was glad for the work that Enzo was working on that, and hopefully we'll have some patches. So just repeating something from last year's presentation, SMB Direct is another area where we have some fantastic SMB features, this framing layer for getting it at RDMA easier. Tom Talpio and Metz had some great ideas, pulling out some of the SMB Direct code into common code that Samba could use, that the kernel and client could use instead of having it in separate code right now in the kernel and client. RDMA for the world, right? Make this easier for more places. So anyway, I wanted to thank those guys for some of the work, but that was a point we brought up last year that we need to follow up on more. There are some recommendations, if you want to look at this, these are some recommendations from last year from the discussion. And then I want to close with one obvious thing. What matters is testing. These test events are invaluable. Running more XFS tests is invaluable. We run a large number. At the moment, our build bot is dead because of a problem, not an SMB problem, but a problem with the config that got messed up. We are running, obviously, lots of automated testing, but this is something that we want to focus on. We want to continue to add XFS tests. We've added quite a few over the last 18 months. 245 tests typically on every check-in we would send to Linux. We need to get over 300, or that's a big deal. Samba is obsessive about testing. SMB torture and various other automated testing, we need to be the same way. We run a lot of tests before every check-in, but the lack of the build bot being down actually caused some regressions that Tom found. So, you know, one of our priorities is re-enabling some of that automation so we're not having to run it on local developers' machines all the time. There are detailed wiki pages on samba.org that explain this in detail and which tests are run, that have some scripts and some ideas and show you how to set it up. This can be very helpful. Okay, so it looks like we're running out of time, but I do want to thank you for your time and see if there was any last minute questions before we get kicked out by the next talk. Anybody have any questions? So Paolo, do you have a favorite bug that you fixed? I don't know. Nope. Okay, so I do encourage any feedback. Please, on here you can see additional resources. You can contact us. We're at the Plug Fest. You know, feel free to ask us questions. And go ahead, question.
Do you interact in any way with the teams at Microsoft that work on the Windows SMB servers?
Yes, so Vladimir, we just had a Q&A yesterday with him. I probably talk to him once every 3 or 4 weeks. I don't want to contaminate Linux with Windows code, so I have to be very careful about boundaries. But we do interact from time to time, and there are some exciting things going on that they were discussing. So Ned had a great summary talk that indicated the changes. I guess for good or bad, there's very little that affected the protocol flow on the wire, like the spec. There's very little that affected the spec this last time, which was good. But you know, I'm particularly interested when he has advice that can help us on the Linux client to behave better to Windows. And one of the things I would love to do, and if you guys have ideas, this would be great. There's times when NTFS has specific features that aren't exposed over SMB, but that would be useful for Linux. So if you're aware of things like that, maybe we can get, in some of those cases, those features to get exposed. And part of the reason I think about that is when I look at individual skipped or failed test cases, there's things that Neil Christensen or Ned or these other guys would be aware of on Windows, the equivalent, but we're interested in the Linux, but we don't know how to ask them to make sure they expose that feature. Anyway, this comes up a lot, but we do talk with the Windows team from time to time, and obviously I'm on the Azure file side, so there's a separate server team that develops the Azure files, and we talk to them every day. But the Azure file server is smaller in scope because it has to be very secure for the, you know, the cloud. Okay, anything else before we finish? Okay, thank you guys for your time.